Oh, Coco! You look a little different. Alright, anyway. Here's what we're going to be doing now. We're going to be doing the exact same problem. Same thing as before. It's just now I'm using a slightly different technique. It's called the addition-subtraction method. You actually use multiplication and division just as much as you use addition and subtraction. So I don't know why they call it the addition-subtraction method. Maybe it's the addition, subtraction, multiplication, division method, but maybe that's too long of a name, so they just said, dude, it's just that you add and subtract it. Or maybe the cancellation method, that might be best. Here's how you use it. It's pretty straightforward, okay? Let me do this. I have y plus 2x equals 14. I didn't change anything. I just copied the top equation now. But what I'm going to do here is I'm going to multiply the bottom equation by the number 2. First of all, let's make sure that I'm allowed to do that. 3y plus x equals 12. Am I allowed to multiply the entire thing by 2?
Yeah.
That would make it 6y equals, or plus 2x equals 24.
Yeah.
But I'm totally allowed to do that because I can divide everything by 2 and then get back exactly what I have. I could reduce this by dividing everything by 2, and I would get 3y plus x equals 12. That is totally allowed. Does that make sense?
Yeah.
I can't, however, just add 2 to both sides. That's not fair.
Okay, yeah.
That's changing the equation inherently. Does that make sense?
That would make it 5y plus...
No. If you add 2, then you don't add to the y's, you don't add to the x's, you add to the 12. But that would change the equation significantly. But if you multiply or divide by a number across the board, it will be fine. Are we cool with that?
Mm-hmm.
So in my head, what I'm going to do is instead of, I wrote the top equation, I didn't change it at all.
Okay.
In my head, what I'm going to do is I'm going to multiply the bottom equation by the number 2, and that would make it 6y plus 2x equals 24. Are we cool?
Yeah.
You sure?
Wait. You multiplied this one, right?
Yep.
Yeah, that's what
Coco, you sure?
said was okay.
You guys learned that as I ask you, are you sure? Is everyone sure? Are you good? Are you good? That I always say, because all y'all are wrong. All right, are you cool with that? Come on, Tejas.
You were just saying that that's okay to do, right? So,
Yes,
yeah.
it's okay to do. Did I do it right?
Yeah.
Yes, I totally did it right. I'm just messing with you now again. And you guys are right this time.
Remember yesterday when you said you could be a jerk?
Yeah. Yeah. Am I being a jerk now? Okay, sorry. All right. So, the reason why I did this, the reason why I made this 2x is because what I'm going to do to these two equations is I'm going to subtract them. Actually, personally, I don't like subtracting things. It confuses me, to be honest. Okay. Instead of doing, I know it's a little weird. Instead of doing like 4 minus 3, oh, you can't even see that because of the red. Instead of doing 4 minus 3, I like thinking of it as 4 plus negative 3. That's doing the same thing,
Yeah.
right?
That's more confusing to me than that.
Well, in this case, it won't be more confusing. I'll show you why. Well, what I would do is I would say, okay, well, what I'm going to do is, if it's 4 minus 3, I'm going to take the 3, I'm going to multiply it by negative 1, and then I'm going to add that to the 4.
That's more confusing to me.
I know, but hold on, watch. I'm going to subtract this equation from this equation.
Okay.
But what I would rather do, I'm going to do it my style, is I'm going to multiply this bottom one by negative 1. So it just changes the sign on everything. Now I'm going to add them.
Okay.
So, y minus 6y.
Y minus 6y is 0.
No.
No.
No. Y minus 6y.
Oh, y minus 6y. I'm sorry.
1y minus 6 y's gives you how many y's left over?
5y.
5 y's? Close. 1 y, 1 apple, take away 6 apples is what? I know, it's a little weird to think of it. If you have $1 and you owe me $6, then what do you have?
-5.
Then you have -$5. You actually give me your dollar and you still owe me $5. How's that for being a jerk? Alright. Does that make sense?
Yeah.
Do you understand why the one? Alright. The 2x minus 2x is what? You have 2 x's and you subtract 2 x's. What do you got left?
A huge divorce settlement.
That's funny. No. Alright. What do you got left? 2x minus 2x rhymes with hero. So it's
Zero.
0x. There's no x's left. Are we cool with that?
Yeah.
So I'm not even going to write anything because it's 0. 14 minus 24. What is that?
14 minus 20 is -10.
-10. I'm good. I'm glad. Solving for y. Divide both sides by -5. Right? Boom, boom. Y is equal to 5. No, 2.
Wait, what?
-10 divided by -5
Oh,
is
divided,
positive
sorry.
2.
Yeah.
Yes, I agree. Y equals 2. Look.
Cool.
Alright.
I like this way better.
Let's figure out what x is if y is equal to 2. And I told you that once you figure out one of these, you can take it and plug it into here. And you can figure out whatever, you can figure out the other variable. Because what I'm going to do is I'm going to take it and plug it into the bottom one. Normally, I would probably plug it into the top one because the top one just looks like an easier equation. I'm going to plug it into the bottom one just to show you that I could.
Okay.
Let's plug in this 2 into here. And what is 3 times 2?
3 times 2 is 6.
So really what this is saying is 6 plus x equals 12. Right?
Oh, yeah. Okay. Makes sense.
We good?
Yep.
Yeah? Alright. Get x all by itself. What do I need to get x all by itself?
Divide by, or subtract by 6.
Subtract by 6. It's not divided because it's
Yeah.
being added to
Yeah.
it. So subtract by 6, subtract by 6. I got x. This cancels out over here. I get x is equal to 12 minus 6, which is 6. Hey, guess what? That's right here as well.
I like this way better than the last one.
Okay, so here's what we're doing, all right? We did this in the first method. We did this in the second method. We reduced the equation to one variable and one equation. We had 2 equations, 2 unknowns, okay? See, we didn't know both y and x, and we had 2 different equations. We used this addition subtraction method to reduce it down to one equation and one unknown. We did that in the previous problem. We had something written up on the board that said something like 3 times -2x plus 14 plus x equals 12.
I don't like that.
Look, this is what we had up when Coco was up here, right? And this is still one equation and one thing we don't know. We're doing the same thing here. Why did I multiply by 2? Why did I multiply this bottom number by 2? I'm asking you that.
Why did you multiply?
If you have
This
this, if
by
you have
2?
this, why did I multiply the bottom one by 2?
To know that you can then again go back to this.
No, but why did I choose 2? Out of all the numbers, why did I choose the number 2 to multiply the bottom one specifically by?
Because 3 is just too many.
Do you guys know?
I don't know. I don't know.
Because in the addition subtraction method, your goal is to get rid of one of these variables. And I needed to make this 2x be the same as that 2x. So that when I added them together or subtracted them, 2x minus 2x equals me 0. And that got rid of all the x's.
Okay.
Does that make sense?
Yep.
We cool? So I chose 2x down here to multiply this by 2x because I knew that I needed to make that 2x and that match.
Okay.
I could have, however, multiplied the top one by 3.
Right.
Because then that 3y will match that 3y.
But then that would have been 3x, right?
No. If I only multiply the top one by 3,
only the top one. Oh,
Yeah.
okay.
then these 3y's will cancel, and when I add this, all the y, you know, the y information will disappear, but I'll only have the variables in x.
Would it come out the same again?
Well, let's try it. And I'll do it real quickly for you. Don't worry, I'm not gonna.
Okay. I was like, oh no, I shouldn't have asked that.
No, I'm not gonna put you on the spot for that one. But you're curious. If I multiply the top by 3, I'll have 3y plus 6x equals 14 times 3. That's 42 again. Yeah. And then I'll have 3y plus x equals 12. And I didn't change anything on the bottom of my equation, but I changed the top one by multiplying the whole thing by 3. The whole reason to do that is to make these the same.
Okay.
Now, if I straight up add them, then they won't be the same. So you subtract them, right? Now you're saying, hey, I don't like your multiply by -1. You don't do that.
Well, actually, now that you explained it the way you did it,
I'll show you why. It's because when you subtract this, you need to make sure to subtract this one and subtract this one and subtract this one.
Okay.
And I always forget that. I'll always go, oh, it's 3y minus 3y. Okay, that's 0. And then 6x plus x. Oh, no, you need to subtract this. So what I like doing is I like adding and then changing the sign on it.
Okay, I see. Yeah.
That's the reason why. All right. So then this 3y minus 3y, that goes to 0. I don't even need to write it. 6x minus x is 5x. 42 minus 12 is 30. 30. So x is equal to 6.
So it comes out the same.
Comes out the same.
Okay.
Got it?
This kind of looks like the one you did with cocoa.
All right. My suggestions. Why would you do? Why would you use the substitution method? Why would you use the addition subtraction method if they come out to be the same? Which one do you find easier, Coco? Which one do you like?
I think the add and subtract one.
You like the add and subtract one? What about you?
I like this one. Add and subtract one.
I agree.
It was less confusing. It didn't go this far down.
Well, but I'm setting up this whole concept for you, so I mean, I had to have a lot of background information. That's why I spent so much of the work. I would say this. One of the reasons why I like using the addition subtraction method over the substitution method is when it looks like this, when I have it in standard form and standard form. Does that make sense? But if I'm given the problem like this, solve this problem. Y equals negative 2x plus 14, and 3y plus x equals 12, or something like that. In this case, I would use the substitution method. The reason being is because I already have one of the variables solved for. You know what I mean?
Yeah.
So it's easy for me to substitute it in right there. Boom. You know what I mean?
So then you would just do 3y plus
It would be 3
minus
3 parentheses,
Yeah.
negative 2x plus 14.
Yeah.
Because that's what y is, plus x equals 12.
Okay.
So if a problem has one of the equations that it's easy to solve for the x all by itself, or the y all by itself, I would use the substitution method. If a problem has it so that maybe I'll have something like confusing, like, I don't know, 4x plus 2y equals 12, and 3y minus 7x equals 17, or something like that. In this case, I would use the addition subtraction method.
Okay.
Because
You don't have.
it's not easy to solve for specifically x all by itself, or y all by itself. See what I mean? By the way, when you use the addition subtraction method, you need to remember also to do this. You need to line the x's up with the x's and the y's with the y's vertically. So I would probably change this to negative 7x plus 3y. It's the same thing, I just moved those things around. Does that make sense?
Yeah.
Okay. Yeah, we can stop the video.